Let's hand it over to Armando to talk about from zero to
All
hero
right,
on
so
Microsoft Spark.
it's going to be Armando, the voice only, no image. And sorry for the confusion on the link to get connected. Let's get started on this zero to hero on Spark. So Kevin has already introduced some of the Spark, some of the concepts about Spark, right, Kevin? I got you finishing up that Spark. I was developed is an open source project. I think I heard you saying that, and asking some more of my questions in there. Just briefly, my name is Armando Lacerda. Can you see the mouse when I move my mouse?
Yes.
All right. Yeah, my name is Armando Lacerda. If you want to connect with me on LinkedIn and keep the conversation going there, that's my preferred social network for this kind of content. I do have a Facebook, but it's more, personal stuff, travels and these things. If you want to keep the conversation going after this, after finish up the session, please find me on LinkedIn. Kevin, just for my check here, are we wrapping up at the top of the hour, or can go a little longer?
We can go a bit longer. We can go as long as you need.
Okay, cool. So moving on. All right. So the agenda will be pretty much three topics, right? Apache Spark, which is an open source project implemented inside a Microsoft environment. In this particular case, in Microsoft Fabric. It does exist in other environments like Synapse Analytics, which is the predecessor of Microsoft Fabric. So we'll be talking about that as we move along. We will see the connection in between notebooks that has our code to be executed on the Spark platform. So we're going to see the elements surrounding that one and the options in there, and demos all along. So not that many topics, a lot of demos. That's the idea. And you guys have already have asked questions already. Keep them coming. At the end of the presentation and the demos, I will love to try to answer your questions. So Microsoft Fabric is, if you're not that familiar with Fabric yet, Microsoft Fabric is a collection of services that were stitched together. And I'm planning on creating this other short video, just to making fun of Microsoft product names. They come up with all kinds of names, and then we're trying to make sense of those names. Like I said, the predecessor of Microsoft Fabric was Synapse, and they borrowed that name from the human body when the neurons connect to each other and they send information across. That's a synapse movement that happens in there, right? When they send signals to one to the other. So it kind of made sense. Now, when it came to Fabric, the only thing that came to mind was like, it must be like a shirt or a dress or something. And then it came to me the other day, oh yeah, they stitched all the services together. So they kind of create a fabric because they stitched all of them together, or patchwork or something. So I don't know how they came up with these names. The bottom line is Fabric is a sort of a umbrella name for many services already integrated in one platform. And the beauty of Fabric is that, right, is that you don't have to spend hours, perhaps a couple of days, trying to authorize one service to interact with another service. Everything in there is already authorized to connect with each other. The user permissions would be in place when it comes to authorize a user. And the data is shared, it's accessible to all of them, regardless which server generate the data or process the data last. So it makes the life of data engineering, of working with data in general, way easier than it used to be. So we've been working with Fabric for a while. Those of you who have been working with Fabric or just experimenting right now, you are probably experiencing that as well, right? It's way easier, way more streamlined to connect to data and process the data. But each one of these services, this is not comprehensive. There are more services there, especially on the streaming side of things, on the real-time analytics and data activator. There are some more options in there. But when Fabric was released last year, November last year at GA, This was the main; those were the main elements in there. It's, I think, still they still are the main elements that show up in the Fabric homepage. Today, we will be focusing on this guy, right, on the data engineering side of Fabric. And they call it the data engineer because it came from Databricks. I mean, it came from, supported by Spark, so it's around the Databricks universe. And in Databricks, we do most of the things there we do by coding, by creating code for data transformation and dealing with data affairs there. And if you create code, usually you are a developer. But if you're creating code to process data on a Spark environment, then you are a data engineer. And they made this experience in Fabric called the data engineer, where most of the transformations we do is supported by the Spark engine. The other engines in there that are grayed out right now, the other engines that are there, they use other data engine. I mean, they use other code, right? Other piece of code. But the most important thing to keep in mind is, regardless of which option I come to choose to process my data, the data it's saved in one lake. I'm gonna go back here one slide. The data is saved into this conceptual store called the One Lake. And in there, it's available to all other engines because the whole platform speaks one file format, which is the Delta Parquet file. So if I process data with data engineering, like we're going to do here today, once the data is processed, it's there. The data I could query that data using a SQL engine, which is the one in the data warehouse. And if I come to transform data in the data warehouse down the road, I can query that data from the data engineering the same way, collect the data. And when Power BI reads the data, it doesn't care. It really doesn't care which of these two created the data. It will get the data there and read and process and render the visuals. So the data engine you come to choose becomes a choice, a strategic choice based on the team, the people who are working with Fabric and which language or environment they are more familiar with, and sometimes specific features, like Kevin was mentioning when I joined the session here. There are some specific libraries, and there are some particular libraries that only work on data engineering. They are not available in the data warehouse. The data warehouse, it wants to work with data in a structured format, like in table formats. It has to be tables. If you want to work with data that are semi-structured or non-structured data, like video, pictures, and these things, and want to do machine learning on top of that, you got to go into data engineering. The SQL engine is not ready for that at this point. It's not designed for that. So it becomes more of a use case application. Depending on my use case, one or the other may be the best choice, or either one if I don't have any specific that will be covered by one engine only, right? But again, we will be focusing on data engineering and particularly in the Spark engine. So the first thing we're going to take a look is the data pipelines and movements that can happen within Fabric. I think my browser is still here. Let me see. Yep, here's my browser. So when I go into Fabric, and just for fun, let me hit the home page, fabric.microsoft.com. Of course, I'm going to use my account. This is a demo element that I have in there. Yeah, there we go. So it's still the same. Still the same 8 icons I had there on my slide. So when we hit in here and we decide to go, I'm going to do some data engineering work, my choice in here will define how the interface will behave for me. Again, the whole Fabric is available to me all the time. This one is just the experience, what shows up first here on the buttons and everything else on the top of the page, right? But if I want to switch to the other experience, I can go over here and switch to the other ones. Or, if I just want to create something that belongs to another experience, I can go here on create and choose from all options that are available to all experiences. So this is just a navigation element in there. And when it comes to uh, data engineering, most people like to use the medallion approach, right? When we do bronze, silver, and gold. And when we do that medallion approach, we have processes that will be bringing data from an external source, whatever the source is, on premise, some other cloud service, into Fabric. Now, here's a big important thing to note when we start work with Fabric and the Spark engine. Most people who come to Fabric and start working with the Spark engine, they have some Databricks background. And in Databricks, we usually do this data movement from the external source into our storage, into OneLake in our case. In Databricks would be the data lake. we do that in Databricks in the notebook itself. And because there is a great level of compatibility in between both Spark engines and Databricks and Fabric, we could do data ingestion through the notebook, like I was saying. But the best practice inside Fabric is actually not to ingest data into OneLake using the notebook. Even though it's possible, technically it's correct, there is no problem. But you would have a better experience, especially if you're ingesting a large volume of data, when we create a data pipeline. And in particular, inside the data pipeline, there we go, it's creating it for me. Give it a name. Apparently, I already have one there. Oh, hold on. Let me choose the right workspace here. Let's click this guy, try pass, because in Fabric borrowed that from Power BI, right? Everything you create must be within a workspace. So I have a workspace here with some demos ready for our session. But like I was saying, I can come in here and create a pipeline. As you can see, there are multiple ways of doing the same task, right? I was creating a pipeline from the other button there on the home page. Now I'm creating a pipeline here from the new button. They all create the same kind of pipeline. So try pass pipeline. Yeah. So when you want to ingest data inside ingest data to OneLake, right, inside Fabric, what you want to do is to use this particular, they call it activity, right, this element in here, activity, to bring data, especially when it is in high volume, right, when you bring like terabytes of data and you want to have some parallelism going on in there. This is the option you want to have. This compares, it's not the full blend, but somewhat a subset of Azure Data Factory that we have in Azure. But here, it was simplified. The experience was made way simpler, with fewer knobs to turn up and fewer options you have in the app to accomplish the same task. So we can do orchestration from here. And this particular copy data activity here does not use a Spark engine, right? You use a particular collection of code there, a set of bits to run the parallelism, to run code to import data in a parallel fashion inside Fabric. So this is the one you want to do. And to be a hero in Spark, one of the things, the first lesson here is sometimes we don't want to use Spark for some particular tasks inside Fabric, because there is a better option, more integrated option in Fabric. This is one of them. The other one, which I'm not gonna dive into here, is when you process streaming data, right? Fabric has other options than the regular Spark support for streaming data. They're way more scalable with way more options in there, but that is a conversation for another day. All right, so this is the pipeline. But within the pipeline, once the data is ingested, perhaps into a stage area inside your one lake, that's one of the reasons that when we create a lake house, I have one lake house here for demo. When we create a lake house, we have this file section and we have this table section. So when you do data ingestion and then bring data from sources, usually we, one of the common practice out there is to bring the data as plain text, as string for all, if it's supposed to be somewhat tabular, so we bring the data as CSV files, for instance, because then when you get into bronze, so this will be my stage, and bronze would be that data just that landed in files as tables inside the lake. I will do all my data type choices. And when I do this data type choices, it's based on what is supported on the Delta table table data types. So yeah, so if you're doing that ingestion on the pipeline using the copy activity, you may want to land the data here on the files. And when it's time to get the data that's already in one lake into the tables, then it is time to use your Spark support, right? So when we create a lake house, and that's another important thing to keep in mind. If I go here to my workspace and choose from possible options here to deal with data, I have it here, the lake house, and I have the warehouse down here, and I have the lake house over here. Now, this is an important thing to keep in mind when we're working with Spark, right? My storage is one lake. And in the Microsoft documentation, when you go to learn.microsoft.com, sometimes it's a little confusing because they refer to the lake house and the warehouse as storage destinations. And they're not really storage destinations. I was there talking to some of the people in the product team a couple of weeks ago there in Redmond, and we were having these conversations over some drinks. I was telling the people there, look, this is not really a storage destination, because the storage destination is one lake. What you have in here is when you do the lake house, you are making a choice to process the data in or out of the lake through a Spark engine. And when you do the warehouse, you're making a choice to process the data in or out of one lake through a SQL engine, right? What used to be the Azure SQL Data Warehouse, then it became the Synapse dedicated SQL pool, and now we have a new iteration, the next version, if we're still using the version terminology, which is this guy here. So the whole data, it always stays in the lake house. This is just your option. So a Spark hero would understand that if I want to work with Spark and process my data that's in one lake, anywhere in one lake, using Spark Compute, I have a lake house created just to tell the environment that all my processing is to be done based on a Spark cluster, right? So that's why I have a lake house in here. And when we get the lake house, let me go back there to the lake house. When you get the lake house, you have your option both to write your code in here, which will be investigating in a second, as well. And when you get to the code there, you have also your option for the Spark engine you'll be working on. And once you create your notebook to process your data, see, I have some data here waiting for us already. Once you have your notebook ready to process your data, let me see, I had it here somewhere. Just this one, yeah, this is it. I can come in here and say, you know what? Now I want to process. I want to execute. Come on, bring it there. There you go. I want to execute the notebook, And when I do this, when I execute the notebook and define, the orchestration settings of that, the sequence, who comes before whom. But when I get in here, then I will be executing my notebook into a Spark environment that's associated to the notebook. And then I have here one notebook there for us to take a look as we move along. So the environment where this is going to be processed is defined in the notebook, and the notebook, of course, will run on the Spark subsystem, right, in the Spark cluster inside Fabric. So that's the thing about the pipelines, right? When you inside the pipeline itself doesn't process any data, so it's just a graphic user interface to define the orchestration of the notebook executions and other tasks you may want to do as well. There are a few other tasks that are in there, some logical controls and everything else. But this the Spark processing, or the Spark environment that will execute our code would be orchestrated from here, and in a way, sort of a no-code approach. So we have the data pipelines for data movement. And when we do those data pipelines, we can do the notebooks, as I have just shown, and the notebooks would be code-based transformations, which is going to be my next slide. If I don't want to do code-based transformations, I have the option to do data flows. But when I do data flows, I'm not really running my code into Spark. It's one of the other engines that exists inside Fabric that will support the data flows processing over there. The bottom line is this one here, it's a way easier experience. It's pretty much based on drag and drop and has a few limitations in there. One of the limitations, if memory serves, is like I can only bring in up to 50 data sources. Like if they are structured data, like tables, only 50 tables in parallel at one time. While when I do the pipelines with the copy activity, I can parameterize those and have them process as many tables as there are there. So there we go, right? So this is the UI based and no code and pretty much no Spark support in the back end because there is no data transformation. Now, when I want to do no data transformation, the pipelines and the data transformation data flows is based on another engine. Now, if I want to do Spark, then off I go, right? I go on this side here where I have two options. One, I kind of glanced over already, which is the notebook. We will run on top of a Spark cluster. And the other one is the Spark job definition, which is not as popular as notebooks. You don't see that out there much. But what it does run on top of Spark, and what it does is you give a Python script. Actually, let me demo that. I mean, just glance over here just quick. I can come here to my workspace. I have one here that I created beforehand for this session. So yeah, what we're doing here, we can upload our code, right, as a Spark, as Python code, kind of a more generic code, not really a data engineer, or we can call other resources from here within Fabric, right, like the Spark jobs from our code, and then run them from here. And this would be for more generic processing that is supported by Spark. It will be set up as a Spark element in there. And but again, not really target to data to ETL process, right? To data engineering is more for generic processing there. So there we go, right? We have these two options here that are really based on Spark engines. A little bit about data storage. We kind of glanced over already before we dive into the actual Spark platform. So a little bit more of data storage. Like I mentioned before, there is one storage, which is the one lake, and this an abstraction of possible multiple storage places. For instance, let's say you work for this multinational company, right? It's a worldwide company. They have offices everywhere, here in the US, in Europe, in South America, in Africa, many places. And because of regulations, your office in Europe must keep the data that's processed inside Fabric in Europe, and the office here in the US, specifically here in California, must keep the data local, also in a data center here in California. So, you have these regulations have to keep in there. It's one tenant for one company worldwide, but I need to have my one lake that covers the entire tenant. Is one lake. You cannot have 2 lakes, 3 lakes. It's just one lake. But then physically, you have to segment that lake into locations, into regions, in order to be compliant, right, with regulations. So one lake does support that, and there is a way to do this, which is kind of outside the scope of this session, but it's through the Fabric capacity. When you create a Fabric capacity to support the workspace, when you create that one, it will define where the data will be physically stored. It may be processed somewhere else, but it will be physically stored in whatever the capacity is allocated. So the bottom line is, it's one lake, regardless where the data is stored, in whatever region the data is. Any of the data engines that we have in Fabric will be able to access that data, as long as the person who is trying to access that data has permission for that, and we'll be able to access that data and process that data. So there is only one lake, logical lake, can be physically multiple places, but regardless what the data is, the data engine that you decide to use will be able to tap into it, as long as you have permissions. Just keep in mind that if your data engine is in California and your data is in Europe, there could be network charges, right? When you process data across regions, right, across zones inside Azure. The whole thing is backed by Azure, so you could have some network charges when you go around that. But again, pricing is usually another topic for another session. It's another a beast in itself. Okay, so even though, and this is an important thing to keep in mind, even though the data is stored in one lake, when you go into Fabric, you're going to switch here to the browser. When you go into Fabric, and let me go here to my workspace here. When you go into Fabric, there is no place here in Fabric where you could ask to see the one lake. Let me see the one lake. So I cannot come in here and ask to create the one lake, because it's not an option. When I enable Fabric for my tenants, one lake is available there, and that's the lake. Done. Bang. So you cannot create the one lake. You enable the one lake when you create the tenant, and you cannot see the entirety of one lake from here. You can create this one lake data hub, where you will be able to see the data that's available to you, to your account. But if your account is not the top, the administrator of the entire tenant, more likely you will not be able to see everything that's available there in the one lake for your tenant. So usually, if someone really needs that, what we do, we create applications that will make API calls to Fabric to see everything that's there in one lake, as long as I have permission. And there is also this extension for Windows File Explorer to see the files that are in one lake. That extension uses that same API to see what is in there. The bottom line is, what I'm trying to say, right, is when I start working with Fabric and I'm going to do some data engineering using Spark, when I create things in Fabric, I create in a workspace. And one of the things I create in the workspace is the lake house, which points to my choice of using Spark for data processing. And I will see data that is visible through the lake house, which means, I'm going to go back to the slide deck, which means that these elements that I'm going to choose, they belong to a workspace. And whatever is in that workspace is my window to what is available in one lake. It's important to understand that OneLake has way more data than my workspace can see. And when I choose to work with Lakehouse in order to leverage Spark Engine, I will see the data that's in that available through that lake house, which is usually a subset of the data that's available in one lake for the company as a whole. So it's important to understand the scope of things when you are working with this. And if you need to work with data that is stored in one lake, but was processed in a lake house in another workspace, then you have to make use of a resource in Fabric called shortcuts. So if you're making notes, right, if you're taking notes there, I'm giving you a lot of entry points to other subjects that you guys can research, or again, connect with me on LinkedIn and we keep the conversation going there. Bottom line is, I choose, in this particular case here, I'm choosing data engineering, right, to process my data. I choose data engineering to work with the data that's in one lake, but available through the lake house of the particular workspace where I'm working, where my lake house is placed, right? And my notebooks will be collected, it will be stored. This scoping of the data that's available to me, it's another thing that the Spark hero must understand, because if I'm tasked to work with that data from the other person over there, from another department or something, I must make sure that I have access to that one, and the access would be either through the shortcut or having a process that will transform the data and dump the data into my lake house in my workspace. All right, let me call something here just quick. I'm gonna need this to here in a second. There we go. 1 second here. Think. Oh, all right. Next thing is the data process in itself, right? How we give the data to the data analyst. Because as a Spark data engineer, as a Spark hero, a data engineer that's also a Spark hero, my job description is to process data and make data available for the data analysts to come in and leverage that data. Data scientists, sometimes they're like, get out of the way, Armando, because I want to have access to the raw data and see what's really there, so I can work with that data in my machine learning environments and do my AI work in there. So the data scientists, sometimes they require us to help them with some transformations. Sometimes they would rather do themselves. It's fine. It's a great relationship. But for the data analysts, usually we process the data for them, and then they pick it up after we create some sort of collection of tables, maybe a dimensional model that will help them with their work. So the life cycle goes around this, right? We, as data engineers, we're working on Spark and notebooks, and we are processing that data in the lake house, either in one of the medallion tiers or from stage to bronze, some sort of data transformation. Data scientists may come and also work on the same lake house that we are processing the data. We ingest the data. The bottom line is, for my data analysts, I will end up at some point creating a collection of tables that may or may not be a dimensional model. Usually it is. And they will come with Power BI and collect that data from the dimensional model through another data engine that is inside Fabric called the semantic model. So semantic model doesn't sound like a data engine, right? Semantic model is like a model. It's just tables that are related to each other, perhaps some calculations in there, some measures, some hierarchies, and all of these elements that can be created inside the semantic model. But the bottom line is that metadata in the semantic model is processed by the VeryPack engine that is part of Fabric, which powers Power BI, which powers Power BI. So yeah, so we are here. Spark is over here, right on this corner here. It can be over here too for the data scientists using Spark clusters to process their work. And that's it, right? That's what you're going to find in there. There are a couple other engines supporting all of that. So with that in mind, let's take a look on how to deal with this Spark environment and how to get it working for us. This is just like a brief overview of where you find Spark, where Spark fits, where it doesn't fit, and in the life cycle of working on a particular case, right, inside Fabric, where you would see Spark support. So let's leave the slide deck. Let's head into the environment in here and understanding where the options are and what is available for us, and wrap it up. Okay, how are we doing on time? Okay, almost top of the hour. I think we are good. Cool. So the first thing first, right? I need a Spark cluster. Where do I find my Spark cluster? And the funny thing is, Fabric is so well oiled that it already has, when you start something new inside Fabric, it already has a starting Spark cluster set for my environment. So it's like, if I go here and create a new workspace here just for this demo, like when I create something that I want to delete right away, I usually call it kill me. So I'm not trying to kill myself or anybody. It's just a flag for me to, I can go there and delete whatever is in there. I have no problem deleting whatever I see like kill me, named as kill me. Anyways, here is my my Fabric tenant, right? I'm using the trial capacity there. So I'm going to start a brand new one from here. And when I'm here in the kill me, I will create actually, I don't have to do that right now. So if I want to use a Spark, I need a Spark cluster. And a Spark cluster, as Kevin was mentioned about a half an hour ago, it's a collection of VMs and processes within those VMs that will work as a network of computers, right? Well connected. There is one computer that will control all other computers in the cluster or virtual machines in the cluster to process the data. So there is a driver and there is an executor node, collection of VMs and nodes in there, where when a request comes in, it looks into the request, looks into the data, and dispatches the work on to the working nodes, and slices the work for each work node to work on a subset of data, so we can have some parallelism. So that's the idea of the Spark, and that's pretty simple, right? That's everywhere. Wherever I find the Spark, because Spark is open source, there are hundreds of Spark implementations out there from multiple vendors. Microsoft Fabric Spark is just one of them, but they all have the same idea. So if I want to see that cluster that's available to me, what I do is I go here into the workspace settings. And here in the workspace settings, I find this option here called the data engineering option, right down here. So when I click here on the data engineering, I see, oh, look at that. Look who is here. I see my Spark settings. Hey. And this Spark settings is specifically for the compute side of Spark. So Spark is all about compute, right? But there is, when you have compute, you have the CPU, you have memory, and you have configurations. So the configuration, like if you are Windows, like the registry of Windows, if you are on Linux, the initialization files for Linux, they are not here, right? They are somewhere else, which I will show you later. They can't be accessed from here though, but usually this one here is specifically for the compute definition. And here's the one that told you that it's always there. Every time you create a new workspace and you're going to have processing in that workspace, you're always going to see this starter pool here. See, it's a brand new one right there. And I created this one to show you that without doing anything, you already have a Spark cluster available for you. How powerful is this Spark cluster? Well, by default, it comes like this, right? You can have from 1 to 10 nodes. And as I mentioned, you have one driver that controls the whole thing, and you can have up to 9 working nodes that will be working parallel on slices of the data that was requested by whoever issued the query, or the script, the PySpark script, or Spark SQL script, whatever. So yeah, so this is the capacity there, up to 10 nodes, right? From 1 to 10 nodes. But do I really have 10 nodes? Is that really available to me? And the answer is it depends. Like most of the things in data related work, right? Like since the era of the DBA, the right answer for any question is it depends, because this is about compute, and we are running on Fabric, and compute in Fabric is regulated by the capacity settings, which skill level you have on the capacity settings. And I do have in here, I had it handy here, but I don't see it anymore because I was trying to connect to this session. Let me see here where the browser is. Let me see. Found it right here. Let's see if it's this one here. Yeah. Let me get this link and bring it over here. My screen is going to turn black because I use dark mode on my OS. So yeah, so this is these pools, right? These starter pools and the pools we come to create, which I'll be demoing right after this. These pools we come to create, we can define, like, I want to have 100 nodes there, right? I can go and put that 100 nodes, but it will really have the amount of nodes that my capacity will allow me to deploy, right? To get running in the environment. So if I scroll down here and zoom into this table here, you'll see that information right here. See, let's say you are, like, I'm running a trial. Trial is F64, is this guy here. So if I'm running F64, all other computer engines, they will be regulated around this, right? Oh, sorry, around this 64 capacity units, and whatever they do, they are consuming these capacity units when they are processing the warehouse, the semantic model, everybody else, but Spark. When it gets to Spark, I will have this amount of vCores. Look at the relationship, right? It's 2 to 1. I will have this amount of vCores here available to my Spark cluster if I'm running an F64. And depending on the node size, the node size defines how many cores will be on every node, both the workers and the driver. Depending on the size of the node, I will have a maximum amount of nodes, right, available. And yeah, the max is over here, actually. The max amount of nodes and whatever is the default there. So some people make this confusion. I used to make this confusion, like when I see 64 here, it's like, do I have 64 vCores? No, actually for Spark in particular, I will have 128 vCores, and I think it's 8 gigabytes per vCore, right? When they are deployed. And if my node size is larger, we have more vCores in a node. If it's smaller, have less vCores for a node. So as a Spark professional, I'll be looking to the data, how the data is going to be sliced. If I need more memory footprint to process the data, or smaller footprint and more CPU will make the job faster, then that goes into the fine tuning of my notebook when it gets to execute. Yeah, so, but again, once more, I can go into Fabric and create a Spark pool of medium size 16 cores. But if I bring my capacity to a lower level that does not support that, it will not, the Spark cluster will execute, but will never allocate this, right? Because the SKU I'm running right now does not support that. It may support a spike in the processing in a feature that's inside that's native to the capacity, which supports compute spike demands. And then it compensates over when there is no consumption in the capacity. It's called flattening of compute requests. But it may peak for a while above this queue, but it's not going to be for a long running duration. So you want to plan this accordingly, right? Whatever demand you have, you want to plan this accordingly. Now, if I need to run, like I want to keep my expenses low, I want to keep my SKU on this F2 for the most part. At some particular point of the day, I want to have my SKU pumped up to a higher level so my Spark cluster can have all the processing power it needs to run, and then go back to whatever it was before. That can be done, but as of today, it's manual operation, right? You have to automate that through scripts, so you can increase or decrease the capacity as the capacity compute power as needed, right? It's not automatic as it is today. All right, so this is this. So let's see how that goes into the portal, how we do that in the portal. So here, I can come here into the portal. So you know what? I'm going to create a new pool right here. And again, the pool is all about the amount of CPU and therefore memory available to the Spark experience. So let's say here, again, I can keep this later, right? That's the idea. And here is my my node family. At this point, it is only memory optimized. And here's my node size. Again, the amount of, notice this number here. See here in the corner here. Oh, sorry. This corner here, 10. This 10 here, I can get it up to 32 because of small. I have 128 vCores available to me. Small is 4 vCores per node, so I can have up to 32. But if I bump this to medium, my max number decreases because now I have twice amount of cores per node, right? So that's how I do my fine-tuning if I have to do fine-tuning on this. Because according to Microsoft, Fabric is supposed to be auto-tuning, right? You're not supposed to be so tied up with these options. But at this point, when it comes to Spark, you still want to keep an eye in here so you make sure it behaves the way you want it to behave. And of course, enable at scale, it doesn't mean you're going to have 8 nodes all the time. It can run once if there is no demand for 8 nodes. It can do the job with 1 or 2. It will do the job with 1 or 2. All right, and then I would create this guy. Create, second contain save change. I created, so the options there, kill me, right? So there are my options there. Now I have 2 options. And if I come here and click save, it will save the option there for me. I'm going to step away from here, go back to the demo that I have already set up there for us. This was just for you to see the interactions. Let me switch back to the workspace that I have for this particular session. So in here, if I go back to the same place there, workspace settings and data engineering, Spark settings, it's already there. I have the starter pool that comes with the workspace when we create the workspace. And then I have created my Spark pool here with some other definition. So that is the compute power. What about the actual bits? The Spark engine that will be running within this compute power. So those other options are more into software settings, right? The OS and the environment and everything else. They go here into the environment. And this was a recent, kind of a recent change over a couple of months back, where we can have the same Spark definition and a particular environment to the compute power when running a particular notebook. So in here, it's defining that my environment here is this particular Spark version. Let me zoom in here so you can see this particular Spark version with this particular Delta version. And when they talk about these versions, this is a libraries, right? These are software libraries within the runtime environment. So these are the libraries in there. These are important because they behave differently. So Spark 3.4 has some new features and perhaps some old features that were already there, but the behavior is slightly different than they were used to on the previous version, 3.3. So there can be interface break, right? Contract break in between these versions. So when someone develops something for Spark and they're going to tell you, I'm developing this thing, this code, and this code is supposed to run on Spark 3.4. Especially when it gets to libraries that people use in their scripts, you're supposed to go out and collect libraries. In any library you go, they will ask you, which Spark version you're running. You have to tell them and download the particular compilation of that library for the Spark version. And one of the places you can see that in Fabric is here. The other place, which is the one that really is the valid one, is inside the notebook itself. So if I go here into my lake house, I know that I can process the data that's in this lake house here using Spark Engine, but I need my code. Where's my code? My code is in a notebook. So I can create a new notebook from here, or I can open one that's already there, which I brought it from one of the Microsoft examples from GitHub. I did not create this one, of course, right? Why create one? Let's use one that's already there. So here is my code. Not my code, the code I downloaded. So this code here, it does some processing on the New York tax cab sample tax cab real data that the city of New York makes available on through their websites. So they have a collection of Parquet files there. Used to be CSV. We can use those files. So Microsoft, among a bunch of other companies, they go there, collect those files, and use to do these demos. So I just save time because the notebook itself here is not what is important, right? The important is the Spark engine that will run this thing. So if I want to run, let me get a code here. What is it? Simple code here, just for the sake of test. So if I want to run some code in here, like hello world, I'm a developer, so I have to start with this. If I want to run some code in here, this code needs a Spark engine. So over here at the top bar, I can go and choose to connect to a Spark engine that is, let me get here, a Spark engine that might be already running for my session. And I want to have like through 2, 3, 4 notebooks that I'm executing on the same Spark engine, the same cluster. So I don't create multiple clusters and start over allocating resources inside the Fabric capacity. So, if I'm doing this manually, I'm a data scientist, I'm doing this, I'm going to use this high concurrency all the time because I want to have one particular cluster take care of all my scripts as I run them from tab to tab in my browser. But if I do have a demand that is like I'm going to train this model and I want to have a dedicated pool, the Spark pool for that particular model training, then I would have a standard session that starts a new cluster for every session, every notebook I'm adding over there. So let's say I want to start a new session. I want to grab this guy here, and it's starting my session there. One of the benefits of Fabric is this, right? If you come from Azure Synapse, for instance, or even Databricks, when you ask the platform to start your cluster, it may take 2, 3, even 5 minutes to get the cluster started. In Fabric, for the most part, there are some cases it takes a little while, but for the most part, because in the back end, Fabric tries to keep these clusters warmed up for for the customers when they come in and start process the data. It takes like those 5 seconds to get one of the clusters started. And if so we can come here and start a new one, and will be that quick, that fast. Now, what about that environment, right? What if I need to have a particular workspace setting for my environment, like this one here? Well, these two are kind of the same. This one is associated to a smaller cluster, and this one is associated to a larger cluster. But let's say I need to run this notebook here on Spark 3.3. So I can come here on a new environment, which is also available there on the workspace settings. But here it's actually tied up to my notebook. So I can actually see, the environment is created in the workspace and tied up to my notebook. So I can see on the notebook what's the environment I'm doing there. So new Spark environment 2. And of course, the Spark hero inside Fabric needs to know these things, because in here is where you want to add your libraries, right? Like if my script, the person who created my script, who created the script, or I'm creating the script, and I'm going to use this machine learning libraries, or this particular data processing libraries, ETL libraries, whatever libraries I need, I can start adding them from here. See, from common repository, pipeline, you can get it from there. Or if there is a particular place where my company keeps their libraries, can come here and upload the libraries and have them stored within one lake, so they're local to the workspace. They don't have to be downloaded from external sites. And here, of course, is the compute. We have already defined. I think you're going to find here my 2 computes, right? The one that came to me and the other one that I created. And so definition here, Spark executor core. There we go. And down here, I have, the resources there, like I mentioned here, just settings, right? Spark properties, where I define the key setting for the name of the setting inside Spark and whatever value I want to have for that setting. So all of that is to define a configuration environment for a compute that I have already created. Again, you see, it's one compute definition, multiple environment possibilities for the same compute definition. Every time I execute something on that environment, it will bring up this setting. So it's kind of a one-to-many option in there, which is pretty cool. Lots of flexibility in here. And here is my runtime, like I said before, right? If I want to create a particular, if I need to run this thing like on 3.3, or if I want to test something that will come out in 3.5 and see how my script goes in 3.5 with Delta 3.1, I can come here and choose this one here and publish my environment. Where's my mouse? Here. And publish my environment. Once that environment is published, I can go into the notebook and choose that particular environment definition. Yeah, publish right there. So I can go back to my notebook. Let me see, I don't need to see this environment anymore. Published. I can go here to my notebook, and I can choose my number 2 with the new Spark definition, right? The new Spark bits, so I can test the behavior of that one. Again, it's still in preview, so there are all the gotchas of preview. They can change and all of that, but at least I can start testing the behavior. So if I do this, the old session goes away. The a new session will be started for this guy here when I click connect, and then I can start running my code again. I'm gonna go click the code, and off it goes. Yeah, 3 seconds to get the new one up. Now it's loading the environment in, and my code is executed. Yeah, I mean, like I said, the code in here is really not important, right? We are focusing on the platform that's going to run this code. So we are looking into the configurations and the settings that are inside Fabric to configure a Spark cluster. And for the most part, this is like 90% of the things you will be working inside Spark. For the rest of it that is inside Fabric, you in the documentation you find this collection of pages here. Like if it was a book, would be your manual. This one here, where you see the Spark in the, where is it here? In the Microsoft Fabric, right? You have this Spark node here, and all these options. I mean, all these documentation pages here about the Spark behavior. There are some interesting things here that kind of they address some edge cases like native engine execution when it goes into the when you give up of some Spark features in order to have faster processing with one lake. So like you're not going to create user-defined functions inside the notebook, because they will be using some particular integrations with one lake that would not support custom codes. So if what you can do can be done with the libraries that are there, you're not going to create your own code, your own UDFs in your notebooks, and you want to have better performance, you have this option here. So there are some extra information that I did not share in this session today that you can go and kind of do a research of your own. But for the most part, this is the elements you need to know inside Fabric in order to have a tailored Spark cluster that is supporting your ETL on your notebook or on a Spark job definition that will execute your data as fast as possible in timely fashion. So that's what I have for today. Let's open up for questions. Kevin, are there any questions there?
Well, there are no questions at the moment. However, right now is a great opportunity to drop in your questions in chat. So get them in there. And by the way, if you have a question that's going to be a little bit longer, you can just type in "got a question," and then I'll vamp for a little bit, and that way I don't have to vamp for no reason, but instead I can vamp for a reason.
I got one that I can ask Armando while people are writing questions.
Great.
So Armando, so what do you think about Copilot in Fabric for Spark? If I'm a new person using Spark, how can I leverage Copilot to help me learn Spark in an environment that either doesn't have Spark or already has Spark in play?
Yeah, that's a great question. It does. The Copilot is there. For those of you who are not that familiar with Copilot, I wonder which rock you'll be on. Just kidding. But Microsoft, if you stop by any Microsoft person, they will say Copilot 10 times before the hour ends, right? And Copilot is this Gen AI powered assistant that would help you on a particular task, on a particular environment, whatever environment you are at. In our case here, to the question, when you are in Fabric here, right? When you are in Fabric, and is this the one we're at? Yeah. When you are in Fabric and you are writing your code in your notebook or in the warehouse or in Power BI, there are, my Copilot here is not available. I'm so sorry, I'm not going to be able to demo it. But if you're running on a SKU that's supported, the trial doesn't support it, I would have to have my own paid one for that. It has to be, for that one to be enabled, it have to be on an F64 or higher for the Copilot to be there. But once it's there, you can interact with the Copilot and ask Copilot to look at your code, to give you a piece of code so you can make it better, customized for it. It's a great assistant, right? Better than switching between Bing or Google to search for code on the internet. I myself, I'm not a heavy user of it, but I do use it from time to time when memory is not serving, when it's late at night, and I'm like, how do I do that again? I ask Copilot over there. So that's when you use Copilot as your assistant. In your code itself, you can actually create assets to use with Gen AI to focus either Copilot or one of the Gen AI models there to work with your particular data, right? You can create vector databases, vectors, data sets in here, and right, they make them available to the orchestrate of Gen AI. So you can either define embeddings or groundings for the RAG to have a Copilot working on top of your own data. So short answer to your question, you can use Copilot as an assistant here or create data for a custom Copilot that someone else is developing.
Yep, thank you. I'm not the engineer using Spark, and I actually use Copilot with the magics that come with the notebook and stuff too to help learn how to write this. So for people who are like me, Copilot's a great resource built into Fabric already to help you learn this. If it's something that your company already uses, or if you want to get into using it as well, Copilot's a great resource for that.
It really is. There are some studies where Copilot is used in other platforms like GitHub, and the studies show how more productive people became just because they can get the Copilot to help them out with getting started with the base code. Thanks for the question. That was a good one.
No problem.
All right. It looks like no other questions in chat. So
I have this problem, I intimidate people. People don't ask me. I got here, there were plenty of questions flowing. Now there is none. All right. Again, Kevin, thank you so much for the opportunity to come here today. This was scheduled for last week, and there was a miscommunication with the calendar. And today I almost missed it again because I read the calendar too fast. But thank you for the patience and flexibility. I always love to be, making new friends on these user groups online. Thank you so much.
Hey, we're glad that we were able to get you in here. So we're gonna wrap things up for tonight. Next week we're gonna start over with our July sessions. So Advanced DBA will be next Tuesday. Main meeting will be in person 2 weeks from today, and then the next business intelligence and data science meeting will be 3 weeks from now. So chock full of meetings this month. You'll see them all at meetup.com/tripass as soon as Tracy and I get them up, which should be in the next couple of days. So until we see each other at a future meeting, everybody take care.
Take care.